Good afternoon, everybody. Welcome to the webinar on grid interconnection of micro/mini hydro mini grids. What happens when the national grid arrives? Unfortunately, we could not record our original presentation, and that's why it is a re-recording of the original presentation. All the questions and the answers that were supplied during the webinar, you can find it in the Word document on energypedia.info. Our first presenter for today is Pakayun. Pakayun is the Managing Director of PT Gerbang Multindo Nusantara, a privately owned Indonesian green energy system integration. He has more than 40 years of experience in renewable energy development and energy conservation activities, including those related with rural, off-grid and sustainable development. He has also provided his expertise to a broad range of services in energy planning and auditing, cogeneration, renewable energy development, and so on. Now I'll pass on to Pakayun so that he can present his presentation.
Thank you, Ranisa, for the introduction. Yes, my name is Hayun Budiono. I'm working as the advisory board on PT Gerbang Multindo Nusantara, and for this event, working together with Mr. Adi Nugraha from Interconnection. The presentation is what happened when the national grid arrives, in particular the existing already installed off-grid micro hydro. The first introduction from our company with GMN is the system integrator, as already introduced by Ranisa, and we are focusing on the off-grid areas that include the solar photovoltaic, micro hydro, biomass, and solar thermal. My presentation today, we will talk to stand-alone micro hydro power plant, or MHP, for rural electrification in Indonesia, which has been developed either by government or non-government organization, NGO. For instance, in NGO we have MHP Kalimaron, Yayasan Mandiri, IBK, WWF, Cooperative, and so on. And the government initiative mostly coming from the Ministry of Energy and Mineral Resources, Ministry of Cooperative, and Small Medium Enterprise. Of course, there are still many other government initiatives from different institutions, but mostly on the minor volume. We started the in particular micro hydro plant starting from early 95, where we start the cooperation with the GTZ at that time through the whole technology transfer of MHP technologies and mini grid implementation. This program lasts up to 2008, and then in between we continue with IMIDAP, which is Integrated Micro Hydro Development and Application Program. Then on the dissemination, we have also the PNPM and Green PNPM. This is basically the Rural Infrastructure Program and the Technical Support Unit, which start 2009 to 2012. If we look into the development of micro hydro in general, it grows, but from year to year, as you can see in this activities in this chart, that we start already in 1990, and this is how the installation developed during this period until 2013. The technology transfer that I mentioned, including also the training of implementation of micro hydro plant in Indonesia, that for instance, we can see here the whole group of training and activities that developed in this area. In the national program, we have Ministry of Energy and Mineral Resources, which also provide the regular fund by the state budget since 1995, and this main goal to electrify remote areas and increase electrification ratio. While on Ministry of Cooperative and Small Medium Enterprise (SME), the regular annual program funded state budget starting from 2005, with the main goal to provide the income generation for rural community which based on cooperative. The technical component today, from our long working together with international cooperation, we can manufacture cross-flow turbine up to 1 megawatt and Pelton small tubular propeller turbine, electric load controller, and for off-grid interconnection, we have also manufactured synchronizer protection and regulator. The added value from our cooperation, technology transfer, it now clearly create job creation on micro hydro, and then also develop also micro hydro association, which we also have in the moment the so-called regional training center (ICOM), which is the ASEAN Hydropower Command Center, where we can train on theoretical, also on practical. The electromechanical cost in Indonesia per kilowatt is presented in this following chart. As we can see here, the bigger the capacity, the lower the electromechanical cost per kilowatt. Similarly, also from the total construction of MHP in Indonesia, it provides also the same characteristic with the average. For instance, if you look into the average of 30 kilowatt capacity, then we will have approximately 2.5 or 3,000 US dollar per kilowatt, which is basically that would the price today in Indonesia. The micro hydro project management, if we look into the government funded project, normally the asset transferred to the local, which include district or provincial government, and then the operational normally done by the organization or managed community-based organization, which manage the operation of MHP system. In general, we have 2 operators, 1 head management and 1 secretary, with a total which is more or less 2,000 US dollar per year, where we will generate the revenue of 900 up to 1,000 US dollar per month. The technical complexity, mostly with electronic part, including PLC for the standalone and the synchronizer if it is connected to the grid. What happened when the national grid arrived? Normally, they constructed the MHP by government, remain isolated. I mean that the plant will remain in the mini grid or off-grid scheme. Currently, we do not have guideline to fit into the national grid. There are 2 different grids which we discover: mini grid, which is isolated, and the national grid, which is interconnected through the national network. If the micro project is well managed, normally the customer will stay with the mini grid connection. For instance, in Gunung Halu MHP, we have a 20 kilowatt system in West Java, where the MHP customer about 20 households keep utilizing MHP, and the monthly tariff approximately 2.3 for US dollar per flat per household. If microhydro not well managed, normally the community who has or who can afford the payment, they normally switch to the national utility, which has standard interconnection connection fee of $150, and MHP likely to be abandoned because of no maintenance at all after all the customers move to the utility. For the MHP constructed by NGO, normally asset owned by local community or maybe the private organization, which they are allowed to connect and feed into the national grid in accordance to the applicable feed-in tariff. Just an example from MHP Kalimaron. This MHP originally constructed in 1994 and operated as off-grid scheme. When the government issued the legislation number 1122 in 2002, MHP Kalimaron converted into the on-grid system in 2003 and sell only the surplus to the grid. The additional investment, of course, will include synchronizer, step-up transformer, on-grid lines, transaction meter. So this costs approximately $6,000 at that time, 2003 exchange rate. Cost to fulfill technical standard, because before we connect to the grid, all the system has to be proved by the particular institution that allow that system to be interconnected to the grid. So this will put additional cost of $1,000 up to $5,000, but depend on the site. In case of Kalimaron, at that time we have to pay more or less, or it cost us about $750. The relevant tariff based on current exchange rate, the customer still pay 2.1 US cent per kilowatt hour in average. Well, if you look into the price of the PLN or utilities, it's range from 3, 5 to 11 depending on the consumption. The national utility with the interconnection became new customer for the MHP Kalimaron, and they pay according to the previous feed-in tariff approximately 4 US cent per kilowatt hour. So this is the case of Kalimaron. You can see in the graph here, this is the monthly energy delivered from the plant. The blue colored bar indicating the energy consumed by the community, which is the mini grid marker, while the red one, it is surplus that we or MHP Kalimaron can sell to the grid, to the utility. If we look into the total year, this MHP Kalimaron will have a capacity factor of 85%. And if we put into the average, the electricity sold during 2010, approximately 224 megawatt hour per year, with 26% is the off-grid customer, and the 74% is going to the grid. This gives us the benefit for the community for additional revenue, which originally only approximately only 2,000. Now in total we receive, or the community received 11 something thousand US$, which this indicates the community received more than 6-fold revenue. This is just pictures of Kalimaron, which also the cascade system with Lemah. The Just a short overview on the grid interconnection regulation. We have actually two kinds of regulation, which is IPP regulation and the excess power regulation. The IPP regulation, all the produced power is sold to utility. It is start from 2002, which with the regulation number 1122, as I already mentioned before. The feed-in tariff will be 80% of the BPP local system at medium voltage, or 60% of BPP of the local system if the interconnected into the low voltage. The BPP, or in Indonesia biaya pokok penyediaan pembangkitan, is refers to electricity generation, transmission, and distribution cost, meaning it refers to avoided cost for overall electricity system cost in the province. The higher if the most electricity comes from diesel power plant. Since 2002, we have many regulation changes, and the last regulation, which is issued in 2017, introduced feed-in tariff in accordance to the market price. For instance, the maximum feed-in tariff that the utility can pay is 85% on the local BPP. If we sell to the excess power, only surplus that we sold to the utility, in accordance to regulation number 19/2017, the maximum bid for the excess power is 90% of BPP of the local system. Of course, if we look into this, the higher regulation of bidding in excess power is incentivizing local consumption to reduce the transmission and distribution cost. The result of regulation, and there are 9 already off-grid MHP converted to the grid, and you can also see all the cost related from this interconnection, and then how much is the feed in US cent per kilowatt hour the MHP will receive payment. So in Kalimaron, as in our case already, it is developed as Cascading MHP, which is located in Seloliman village. In addition to the conversion of off-grid MHP, we also have 8 MHP started directly as an on-grid scheme. This includes also in many areas, including Java, Sumatra, and also even NTT. Grid interconnection, of course, will provide many benefits, and we have 3 beneficiaries of this grid interconnection benefit. First, of course, the utility. The utility can have a cheaper cost than its own avoided cost to distributed generation. This also reduces risk of total blackout. For community, there are 3 items that can be called as beneficiary of the community. First, that the capacity factor is improved because the electricity production is higher than it is working as a standalone system. And for commercial, it generates additional revenue for community or project developer. And this also opens the potential to finance the system as the public-private partnership or PPP. The socio-economic benefit with additional community revenue, this would potentially to promote community development and rural livelihood, which is income generating activity, support local education, also health care, cultural activity, and also watershed protection. This is indicated already in many micro hydro projects. which we developed in Indonesia. Also from environment, it provides a good challenge to generate community awareness on the environment and on the improving water management. And also it reduces automatically the CO2 emission from utility thermal power plant. This would end my presentation. Thank you very much for your kind attention.